Here we have the addition formula. We have sine A, and we've got a plus or minus here. And we've read this as two different formula. So we either have the top ones, so sine A plus B. And if it's the top one in the first one, it's the top one in the second one. So it's sine A cos B plus cos A sine B. Or if we use the bottom one, we use the bottom one the next time. So sine A minus B is equal to sine A cos B minus cos A sine B. So each of these can be written as two different formula, one for cos A plus B, one for cos A minus B, one for tan A plus B, and one for tan A minus B. This first question, write cos x plus 30, that'll be degrees, in the form A cos x plus B sine x. So it's the cos A plus B formula. So cos something plus something, cos A plus B. And we're using the top one, so it's the top one here. So it's cos A cos B minus sine A sine B. So if we change A to x and B to 30, we get cos x plus 30 equals cos x cos 30 minus sine x sine 30. And we know what cos 30 and sine 30 are. So cos 30 is square root 3 over 2. So square root 3 over 2 cos x. And sine 30 is a half. So minus half sine x. And that is our answer. One for you to try. See if you can give that a go. So sine x plus 30. So we're going for the sine A plus B. So sine A plus B is sine A cos B plus cos A sine B. And then we're going to change A to x, B to 30. So it's sine x cos 30 plus cos x sine 30. Cos 30 is square root 3 over 2. Sine 30 is a half. So there we have our answer. Expressed as a single sine, cosine, or tangent. So this time we're going to go back from our right side to our left side. So we've got sine cos, cosine with a minus between them. So we could have sine A minus B. Or we're going to have sine A minus B even. So sine A minus B is sine A cos B minus cos A sine B. So we're going to change A into 17 and B into 41. So it's sine 17 minus 41, which will be sine negative 24. The second one, we've got cos cos minus sine sine. So it's going to, because it's cos cos and sine sine, it's going to have to be cos. And because they've got a minus between them, it's going to have to be the top one, which is cos A plus B. So it's cos 68 plus 55, which is cos 123. And the last one, we've got a tan. It's plus on the top, minus on the bottom. So it's the top one, which is tan A plus B. So it's tan 47 plus 15, which is 1062. And some for you to try. See if you can give them a go. So the first one, we've got a sine cos and a cos sine. So it's got to be sine. It's got a plus in between them. So it's the top one. It's sine A plus B. So sine 19 plus 22, which will be sine 41. The second one, we've got cos cos, sine sine. So it's cos. They have a plus in between them. So it's the bottom one. So it's cos A minus B. So it's cos 130 take away 15, cos 115. And the last one, we've got tan. It's a minus plus, a minus on the top, plus on the bottom. So it's the bottom one. It's tan A minus B. 1076 take away 25. That makes it 1051. Another one, without using a calculator, work out the exact value of sine 15. So to get sine 15, we can do 45 take away 30. And we know sine 45 and sine 30. Let's use sine A minus B, which is sine A cos B, minus cos A sine B. So let's change A into 45 and B into 30, and then we'll have sine 15. So it's sine 45 times cos 30 minus cos 45 times sine 30. And then converting these all into their exact values, we have square root 2 over 2 times square root 3 over 2 minus square root 2 over 2 times a half. So we have square root 6 over 4 minus square root 2 over 4. So square root 6 minus square root 2 over 4. Would the calculator simplify that? Square root 6 minus square root 2 over 4. No. Without using a calculator, work out the exact value of 1075. So how can we get 75? We want 1045 plus 30. And 1045 in degrees is 1. And 1030 is root 3 over 3. So we're going to have tan A plus B equal to tan, so we have A and B, tan A, so tan 45, plus tan B, tan 30, over 1 minus tan 45 times tan 30. So that would be 1 plus square root 3 over 3 minus 1 minus, well, square root 3 over 3 times 1 is just square root 3 over 3. I do want to simplify this, so that's times top and bottom by 3 and get 3 plus square root 3 over 3 minus square root 3. And then I do want to rationalize the denominator as well. I'm going to just type it in the calculator because I'm running out of room. So 3 plus square root 3 over 3 minus square root 3 is 2 plus root 3. One for you to try. Give it a go. So it's cos 75 that we want. So we're going to have cos 45 plus 30. So it's cos A plus B, which is cos A cos B minus sine A sine B. So square root 2 over 2 times square root 3 over 2 minus square root 2 over 2 times a half. Square root 6 over 4 minus square root 2 over 4. So square root 6 minus square root 2 over 4. And another question, given that tan A is 7/24, where A is reflex, and cos B is negative 4/5, where B is obtuse, find the exact value of sine A plus B. So because we've got tan A is 7/24, I can draw a right angle triangle, mark an angle as A, and tan is TOA, which is opposite over adjacent. And from that we can work out the hypotenuse, which will be 25 using Pythagoras. It's a 7/24/25 triangle. Because A is reflex, that means between 180 and 360. And tan is positive, it must be in this area between 180 and 270. So our sine and cos will be negative. So we can make a note that sine A is SO, opposite over hypotenuse, but negative 7/25. And cos A is Ka, adjacent over hypotenuse, but negative, so negative 24/25. Cos B is negative 4/5, and B is obtuse. So it's obtuse, and cos is negative, which means sine will be positive. So if this is B, cos is Ka, adjacent over hypotenuse. The opposite must be 3, again using Pythagoras. So we know cos B already is negative 4/5. Sine B is SO, and it's positive 3/5. So to work out sine A plus B, we use our sine A plus B formula. So sine A plus B is sine A cos B, which is negative 7/25 times negative 4/5, plus cos A sine B, which is negative 24/25 times 3/5. And I'm just going to type this into the calculator. So we have negative 7/25 times negative 4/5 plus negative 24/25 times 3/5. And we get negative 44 over 125. So that is our answer. One for you to try. Give it a go. So we've got sine A is 12/13, where A is obtuse. So SO is opposite over hypotenuse. That means the adjacent must be 5, because it's a 5/12/13 triangle. A is obtuse. So sine is positive. That means cos is negative. So cos A is going to be negative, and it's Ka, adjacent over hypotenuse, 5/13. And tan B is 3/4. So if this is B, tan is TOA, opposite over adjacent. The hypotenuse is 5, again a 3/4/5 triangle. B is acute, and all are positive. So sine is positive, which is SO, opposite over hypotenuse. And cos is positive, which is ca, adjacent over hypotenuse. So we want cos A minus B this time. So our cos A minus B formula is cos A cos B, 5/13 or negative 5/13 even, times 4/5 plus sin A sin B, which is 12/13 times 3/5. So negative 5/13 times 4/5 plus 12/13 times 3/5 is 16/65.